There's a misconception that it's impossible to do conceptual design inside of Revit, and that's simply not the case. You can even explore your different kinds of forms inside of the Revit environment. All you need to do is use your massing tools to accomplish this task. Before we use our massing tools, there's one thing I'd like to do, and that's set up this project environment for when we're drawing in our different mass shapes. Underneath the project browser, scroll down until you find your south elevation view, then double-click on south. What I'd like to do is adjust the overall height of our levels. So leave level 1 at 0 feet 0 inches, but let's change level 2 from being 10 foot to 60 feet. Now we can always adjust this later, but right now we'll have the bottom of the building to the top of the building as being 60 feet. The next thing I'd like to do is go back to a plan view and start to draw out the perimeter of our building. So double click on level 1. Then we need to go to our massing and site tab so that we can find our massing tools. So select on massing and site, then click on in place mass. Now you'll get this rather imposing looking dialog box, but all that it's saying is that it's going to turn on your masses inside of each of your views. So no matter which view that you go to, you'll be able to see your three-dimensional mass object. Click on close. It'll ask, what name do you want to give to your mass? I usually just leave it at the default name. Click on OK. Our next step is to draw in the perimeter of our building. And this could be any shape that we'd like it to be. But for this example, we're going to keep it very simple, and it's just going to be a square. So we'll select on the line tool, click once, and then come 80 feet over. Come down and then type 80 feet. Go across until you see the dashed line and click, then come right back up. So at 0 feet 0 inches, which is where level 1 is located at, we have an 80 by 80 square. Let's go up to level 2, which is 60 feet above the square that we just created. This will be the top of our building. And while usually we would draw another rectangle or a square up here, what I'd like to do is have a completely different shape so that you can see how the massing works. Let's select the circle tool. In the middle of this line on the left-hand side, click, come straight up, and then click again. And what I'd like to do now is hit the escape key a couple times on the keyboard to get out of our drawing function. Select on the circle, and now move that circle to a new location. Click on the quadrant point of the circle, come straight over, and then when it hits this line, click. So this will be the top of our building. In order to see what we have so far, let's take a look at it in a 3D view. If we select on the default 3D view icon, we can click, and then we can see that we have a circle, and then we have a square, and the circle is floating up above the square. Now let's join both of these shapes so that it's one solid object. To accomplish that, we'll start by selecting on the circle, hold down the Control key on the keyboard, and then select on the square. Now we need to create a form out of these two shapes. Click on Solid Form. And by doing that, we can now see that we have one solid form that is our conceptual mass. If we wanted to make any changes to this mass, we always could. We could just move our cursor up here. We could just select on part of the circle and then raise that part up. You'll notice how it ends up bringing up the entire circle. We could also select on the little arrow right here, pull it down. Notice how it drops it down. So we're adjusting the overall height of this shape as we're making the adjustments. But there are other kinds of changes that we can make as well. If we would highlight over one of the individual lines, we can then click on one of the arrows, pull it out. Notice how we no longer have a square shape. We're just pulling this shape out. If you want to pull it back, we can do that as well. We could do that with an entire triangular shape. So just move your cursor over here to one of the sides. You may need to move it around a little bit until that triangular shape highlights. You can click on it, click on the little red arrow there. You can pull that out. Notice how that side is now getting pulled out. So you can push and pull on each of these different sides in order to create different kinds of shapes and conditions. What I'd really like to do now is add another condition to this three-dimensional mass, and that is add a void shape to it, which will define our entrance into our structure. To accomplish that, we'll go to level 1 again, and what I'd like to do is create a circular shape. So we'll come up here again to where we have this Modify tab, select on the circle. Right at the midpoint, click once, and then create a circle which is about 30 feet up. Once you get to that 30-foot mark, click once. So far, this shape, the circular shape, is still just a two-dimensional shape. And what I'd like to do is give it some volume, if you will. And this will be volume that we end up taking out of the three-dimensional mass. Now to accomplish that, we'll hit escape a couple of times on the keyboard, select on the circle, then come up here to create form, and then select avoid form. When we do that, we now have two different options available to us. One option is just to create a circular shape, sort of like a can, that goes straight up and just takes material directly out of this mass object. The other option, if we would highlight over the one on the right-hand side, will give us more of a dome shape. And that's really what I want. I don't want just a rectangular sort of can cylinder shape. I want to have more of a dome shape. So let's select on the one on the right-hand side. Let's take a look at this in a 3D view. We can spin it around by either holding down the Shift key and the wheel of the mouse, or by just clicking on the corner of the view cube to spin it around. Now see how we have that dome on the inside of this solid object? I'll also point out at this stage, we can always select on that shape, click on the arrows, we can pull that out, we can pull a little bit farther back in. Each and every one of these shapes, as we're creating them, we can click on it and then pull and push so that those shapes take on the shape that we would like for our final design. Whenever we're finally done, we can click on Finish Mass, and now we have this mass form that we've created for our building. So we can create a wide variety of different kinds of shapes, merge them together, and take material out by using our massing tools. Once we have our general building shape, the next thing that we can do is apply walls to the outside of that shape. To accomplish that, we first need to go to the Architecture tab, then select on Wall. Then we can pick either a wall structural or a wall architectural. And for this example, I'm just going to use a wall architectural. After clicking on the wall architectural, I'm going to use the generic 8-inch wall. We could use some of the more complex wall types as well, but since we're just schematically designing this, getting a feel for the overall form, I want to use a generic 8-inch wall because it's just better for the design process. Then select on Pick Faces. Now there are 3 different walls for this mass that I'd like to assign a generic 8-inch wall to. And that's the 2 triangular shapes that we can see, as well as this dome shape. Let's select the triangular shapes, then see if you can select on the dome shape. Next, let's spin it around so we can take a little bit better look at our walls. Now we can hold down the Shift key on the keyboard as well as the wheel of the mouse, and then move the mouse in order to see these newly created forms. Now these same kinds of commands can work for our floors as well as our roof and any other kind of shape that we need to create inside of this mass object. We activate that command and then draw in the areas where we would like to see our floors or our roofs be located. So far we have 3 different walls associated with this mass object, but we also want to place on the 2 sides some curtain walls. Now unfortunately, if you just select the wall command and go to curtain wall, it'll fail. What we need to use is a separate command to apply the curtain walls to this shape. If we go to the Architecture tab, we can select on Curtain System. Now the properties of that curtain system can be found underneath Properties, then by selecting on Edit Type. From here we can see that it has the option for certain curtain panels, different grid layouts, which mullions we'd like associated with this curtain system. Right now, none of that is assigned, and we could go through the process of assigning all this information if we wanted to. But since we're still just developing the design, I'm not too concerned about that, so I'll just click on OK. But I'm going to point out that yes, you can preset all those conditions. Now, what we need to do is apply this curtain system to those 2 walls that have yet to get any sort of walls associated with them. So we can do that by selecting on the outside face and coming up here to Create System. Do the same thing on the other side, select on the outside face, click on Create System. And now we can see that we have these curtain walls surrounding this rather odd shape of our building. Revit has a tool called Mass Floors, which allow us to see the overall square footage of each of our floors before we even place them inside of the mass object. To understand how mass floors work, we first need to add a level for each one of the floors for the inside of our structure. To accomplish that, we need to go to an elevation view and then set up our levels. So let's go to the south elevation view underneath the project browser. What I'd like to do now is start to add levels to this building. So here where we have architecture, click on level. And about every 10 feet, let's add another level in. So come down here, click, and continue this process by adding in at least 2 more levels. You don't have to add in the exact same levels as me. You can actually have a unique building if you want. That's just fine. We'll come down here, I'll add 1 more level. I will point out you can always come back in here and rename the levels. Right now my levels are in kind of an odd order, going from level 1 to 6 to 5 to 4 to 3 to 2. But I'm just going to leave it like this because it doesn't affect our example. Now the next thing I'd like to do is go back to that 3D view so we can see our building as it currently is. So select on the default 3D view button, and then the next thing we need to do is highlight over the mass object on the inside of all these different walls. And you may need to move your cursor around until the entire form highlights. When you do, you can select on it, and one of your options at that point will be called Mass Floors, which will add mass floors at each of the levels that we select. So if we click on Mass Floors, we can see that we have a variety of different levels. And what I'd like to do is just put a check mark next to every level except for level 6. I really don't want to have a floor up where my roof would be located at typically, so I'm just going to leave level 6 without a check mark next to it. Then click on OK. When you do that, you'll start to see these mass floors get placed all the way around the perimeter of that mass. In fact, if we would spin this model around by holding down the Shift key and the wheel on the mouse, you can see that those mass floors are going all the way around the perimeter of where that mass object is located. If that mass object were to adjust, then those floors will actually stay at the same elevation as what they were, but they'll adjust along with the mass object. What I mean by that is if we would select on one of these areas associated with the mass, and then either raise it up or lower it down, each of those mass floors are no longer just projecting out of the mass object. They've redone their shape so it still matches the outside of the mass, also adjusting the overall square footage of our mass floors. Now, one of the things that I said is that it also adjusts the overall square footage of the mass floors. What that means is that, yes, each one of these mass floors has its own square footage associated with it. In fact, if you would just move your cursor until one of those mass floors highlights, you can click on it and then look underneath properties in order to see all the square foot properties associated with that floor. In this case, this is associated with my level 5, and we can see that the total floor area is 4,980 square feet. If we were to adjust the mass, it'll change from that 4,980 square foot to be a different square footage. And we can see that if I select back on the mass, click on the little arrow here, and then pull it up. Now, if we click back on where that level is at, we can now see the floor area is 5,143.31 square feet because it's now had to expand out to meet the outside edges of this mass object. Of course, since I've made adjustments to this mass, it also means that all of our walls will need to adjust along with it. So in order to make those adjustments to the walls, I'm going to come back through here. I'm going to actually hold down the Control key on my keyboard in order to select on multiple walls at once. Click on each one of these shapes. You can do these individually too, there's nothing wrong with that. Then select on Update the Face in order to update all these different walls at once. Now to see the total square footage and to see them all at once, what we can do is create a schedule, which is a mass floor schedule. Let's go up to the View tab, select on your Schedules button, and select Schedule Quantities. Scroll down until you find your M's and then pick Mass Floor. Right now we're just seeing mass, but if we click the little plus next to mass, we can see a variety of different mass categories, and mass floor is one of those options. If we click on OK, we can now find the different properties we want in our mass floor schedule, and that will include the floor area, the floor perimeter, as well as the level. And I'd like to move that level up so it's at the first of the schedule. Go to the Sorting and Grouping tab, and then let's sort by the level. So it'll be in order by the level. Then click on OK. After you've done that, you can see each of your different levels. You can see the square footage associated with each of those levels, as well as the floor perimeter associated with those levels. And of course, if we were to adjust that mass object again, the mass floors would adjust along with the mass object and automatically update the properties of your schedule. Since you've made it this far, there's a very good chance you already understand how to create different views, create 3D views and plan views, place them on sheets, how to print, and even how to render. Since you already understand those basics, I want to give you a heads up on where we're at right now with this mass model and how it would look if you decided to do a rendering with it. Now, in order to do a rendering, of course, we'll need to go to some sort of plan view and then set up a camera inside of that view that we can render from. So if you go to your floor plans level 1, we can then go to the View tab. Then we need to go to 3D View and select on Camera. And what I'd like to do is render from a spot somewhere out here. So we'll click here, have this cone go to the outside of where your building is at, and then click in order to create a view similar to this one. Also, if we zoom out, we can then stretch this up, pull this up, just by clicking on the little dots. So far, we're looking at the way we think the building will look when it's time to render. Unfortunately, though, as it's set up currently, not as much is going to render as you would think would render. If we move our cursor down here in our 3D view to our little Show Rendering dialog box, the little teapot, we can then select on where it has the quality setting, change it to medium, and then click on Render. It's going to go through the process of rendering all the things that we've applied to the outside of our mass object. You'll notice that the mass object itself isn't rendering. You'll also notice that right now all we have is some glass for our curtain wall system, and then our walls themselves are just very generic walls. So right now, as we're looking at it, we're not seeing those mass floors that we put in there, and it's very hard to visualize the way that our design actually looks. So if we want to visualize it, we need to adjust some settings, add in some real floors, add in a real roof, and that kind of information. Now the process you'd use to do those things is this. Come up here to the red X to close the rendering dialog box out. The next thing I'd like to do is go to our level 4. Technically, we could draw in a floor, which is our next step, from any of our floor plan views. But I'd like to show the level 4 because it's right in the middle of the building and it's easy to see in 3D. When you go to that level 4, you'll see all the walls we put in place. In order to draw in the location of the floor, I really want to shut off all those walls that are currently here in the model. So to accomplish that, we'll go to our visibility graphics, go to model categories, and select on all. Then clear the checkbox next to any of these categories to just clear the checkboxes out. Next, scroll down until you can find mass. Click where it has mass, put a little check mark next to mass, then click the plus sign next to the word mass. Now what we need to do is click where it has form, hold down the shift key, click on pattern lines, which is the bottom of the mass objects. Click the little check mark right there. Click where it has mass floor, then put a check mark next to mass floor. The reason why we did all that is that the only thing that we want to see inside of this view are our mass floors. Click on OK. Now this dark line, this is the mass floor for level 4. Now some of the other gray lines that we're seeing here are also mass floors, but they're mass floors lower down, so farther down with their levels. Now we could adjust our view range so that we're not seeing so far down, but for this exercise we really don't need to. Our next step is to just start to trace around the perimeter of this with an actual Revit floor, because an actual Revit floor will render unlike the mass floors, which don't. So if we would come over here to the Architecture tab, we could come over to Floor, click on Floor, select on the Pick Lines tool, then click each of those lines that make up the mass floor, and then click the big green check mark. After accomplishing that, we can go to a 3D view. And if we look closely, we can now see that we have a floor with real thickness associated with it. And if we wanted our rendering to look good, we would need to go through that same process with each and every one of our levels. It also wouldn't be a bad idea to start adding in any interior walls that you'd like just for presentation purposes. Maybe the walls where you may have restrooms or your staircases, those sorts of things. The next thing that we would need to do is to adjust our curtain systems so that they render appropriately. To accomplish that, we need to select on one of the curtain systems and come over here to Edit Type. From here in the Edit Type dialog box, let's add in a curtain panel, because right now it says that there aren't any curtain panels, and let's make this be a system panel glaze. Next, for each of the mullions, you need to select mullions off of the list. Now, I really don't care which mullion it is that you choose, but I'm going to pick one of the larger mullions, the 2.5 by 5, and I'll use that one again and again for each one of these mullions. Once you have the mullion selected, you can click on OK. Now, this will take it a few seconds to process because it's now adding mullions to these curtain systems that we currently have in the project. Notice how it looks a little bit darker, a little bit more filled out. Now, if we go back to that 3D view, so we can scroll down, find our 3D views, and then double click on the 3D view 1, that's the camera that we placed. Notice how we now have a floor here, as well as the mullions, and there are glass panels in there now. If we had taken the time to go through the process of each and every floor as well as the roof, and then draw in the floor plates and the roof, we'd be able to see those objects inside of the rendering as well. And at this point, we can come down here to the little teapot icon, the rendering icon, and then click on render, and then let this view render. And what we'll find is that all those objects that we just put into place, actual three-dimensional mullions, actual glass panels, and the floor will now show up inside of our rendering. Revit has three main types of walls. One is considered a basic wall type, the next is a stacked wall type, and the third is a curtain wall type. In this example, we have two of those kinds of wall types, the basic wall and stacked wall types. If we zoom in toward the middle, we can see two examples of basic wall types, one which is made up of brick and the other which is made up of CMU. If we select on the brick wall and then click on Edit Type, we'll notice a wide variety of properties underneath the type properties of this wall. Then if we select on Edit next to the Structure button, we'll find all the different layers of material that make up this basic wall type. What I'd like to do is just select on the Cancel button and then select on Cancel one more time. If we zoom out and then zoom up to the top wall, we'll find a very similar kind of wall because it's also made up of brick. It also has CMU, but it also has sweeps and reveals built right into the wall type. Even though it's a very complex wall, at least compared to the other two walls that we just looked at, if we select on it, we'll notice that this too is a basic wall. Now, what makes this a basic wall is the fact that if you take a close look at the side of it, it's actually the exact same dimension from the bottom going all the way on up to the top. Now, technically, any wall that's built as a basic wall would be categorized as being a basic wall. But the defining property of a basic wall is that it's limited to the same thickness from the base all the way on up to the top of the wall. One of the reasons why you'll want to use a stacked wall, and if we zoom to the bottom, is because stacked walls enable us to have walls of different thicknesses stacked on top of each other to make one wall unit. Now, when I call it one wall unit, what that means is that we have two basic wall types embedded into the stacked wall, so that if we would make an adjustment to that stacked wall, such as selecting on the wall, clicking on the little dot, and adjusting its overall length, both segments of that stacked wall will adjust along with that wall. Now, let's also take a look at the properties of the stacked wall. If we click on the stacked wall and then come over here to Edit Type, this is a much different dialog box than what we had with our regular wall types. We only have one option, and that's Structure and Edit. Let's click on Edit. And from here, we can see that we're in the Edit Assembly dialog box, which also looks quite a bit different from the Edit Assembly dialog box of our basic wall types. The reason is that stacked walls are made up of the exact same properties as the original basic walls. In this instance, we have two basic walls embedded inside of the stacked wall. If you wanted to change this so that we had a different wall type selected, we could click on any of the wall types, click the little pull-down menu, and then select any of the basic wall types which are currently loaded into this project and use that instead of the wall type that's currently assigned. If we wanted to add another layer, we could do that as well by coming down here to where we had the Insert tab, clicking on Insert. It would add yet another type, and then we could specify what type of wall we'd like that to be, where its relationship is inside of the stacked wall, as well as give it an overall height. So stacked walls take basic walls and actually just stack them right on top of each other. One of the things here that we can see in the properties of the stacked walls is that it also controls the height as well as how far offset from one another those walls are when they're combined. For the height, we can see that in this wall. We'll be hitting on the cancel button down below, but I want to point out that the top part of the wall is a variable height, which means that can be adjusted. So we can tell this stacked wall to be a certain height or go up to a certain level. But the bottom portion is always 3 feet tall. So if I click on cancel and cancel again, and then take a look at our wall, this bottom half of the wall is always 3 foot tall. I can adjust the overall height of our wall to be whatever height that I needed it to be because of the variable height associated with it. So the difference between a basic wall type and a stacked wall type is that a basic wall type is limited to having one thickness. But a basic wall type also has all those different properties that you may want to create some of your more complex wall conditions with. A stacked wall is simply the combination of multiple basic wall types, stacking them on top of each other so that they have the correct height and can be edited together as a unit. Let's zoom in to the walls we have over on the right-hand side by just spinning the wheel of the mouse. After we zoom in fairly tight, one of the things that we'll see is that we have two walls which are cleaning up or joining with the wall up above. When these different materials touch each other, one of the things you'll notice is that we have certain materials which stop when they hit other materials. Yet some materials will go right through all the other materials until they hit another material just like them, in which case they'll join together. Now, the reason why this occurs and how Revit knows how to prioritize which materials join and which materials don't join is through the properties of the wall itself. If we select on one of these walls, then go to Edit Type, then select the Edit button next to Structure. Here in the Edit Assembly dialog box underneath Function, we can see several different numbers. It ranges from the number 5, associated with Finish 2, all the way up to number 1, which is associated with Structure. These 1s through 5s are actually priority rankings. And number 1 takes top priority. It goes through all the other priority rankings, meaning that if a number 1 hits a number 2, it'll keep on going. If a number 1 hits a number 3 or a 4 or a 5, it'll just keep on going because number 1, it's the number 1 priority. And it'll keep going until it hits another number 1, such as the condition that we see here where this wall and this wall are joining together. Because they're both the same material and they're both number 1s, they clean up on one another. Now, if we take a look at some of these other materials, which are stopping right here at this layer material, the reason why that is that the layer material that's stopping them is the second priority item, the substrate, and it's the number 3s which are hitting it. Since number 3s are the third priority, they don't have a high enough priority number to go through the number 2, so they're forced to stop. So this is one of the main ways that Revit can control which materials go through or take priority over other materials. It's through the function numbers here underneath the Edit Assembly dialog box. Now, if we want to make adjustments to any of these priorities, or the way that the walls join together, we can do that. Start by clicking on OK, and then select on OK again. And click on the wall on the right-hand side. What we want to do is use the tool called the Wall Joints tool. After selecting on Wall Joints, you may need to zoom out just a little bit to see this big box that's going to show up. Highlight over the intersection of these two walls, and you'll see this gigantic box pop up. When you click, You'll notice that we have options on the options bar as far as how these walls can join up. Now, when you have two walls joining the way that these two walls are joining, this is actually the simplest condition allowed. As a result of that, these two walls can only butt against each other, which is why it says butt with a little dot next to it. Also, we have options as far as do we want to allow the join of the wall or disallow the join of the wall to this other wall. With the allow join highlighted, it means that the two walls can actually clean up on one another. But if we select disallow join, we'll see how the two walls actually go right through each other and don't try to automatically clean up each other where they intersect. If you disallow the join of the wall, what you can do is select on the wall down below. Let's hit escape a couple times on the keyboard to get out of this wall cleanup tool. We'll select there, zoom in, click on the little dot, pull it back until it's at the front face of this wall, and then click. And now we can have both of these walls touching each other without actually joining or cleaning up on one another. Now the next thing that we can do is basically the same steps over for the wall over here on the left-hand side. Select on the wall, come up here to the Wall Joins tool, select on the intersection of these two walls. Now let's leave this allow join the way that it is. And there's an option here next to display. It says use view settings. And you can either clean the join or don't clean the join. Clean the joins the way that it was set before. So let's just use don't clean join. When you do that, you'll get the exact same condition that we had over here. Now at this point you may be wondering what's the difference between disallow join and don't clean the join if you can get the exact same condition by using either command. Well, the difference is if we hit the escape key a couple times on the keyboard, we can select on this wall and then pull it. Because this wall is not joined to this wall, it stays in the same spot. And since this wall is still joined to this wall, it's just not cleaning up, it means that if this outer wall would adjust, this wall will adjust along with it because it's still joined. So you can get the same condition as far as how it displays when it's time to print, but one way can be joined and the other way does not have to be joined. Now let's zoom out and look at this middle wall condition. Select on the wall, come over here, and then once again select on the Wall Joins tool. Come to the intersection here, then click. When you do that, we'll now see that we have a few more options available to us. The walls are still butted together, but we also have the option to miter the two walls. And we still have the same display settings and allow join or disallow join. And we'll continue to have those options as well, but we won't review them because they do the exact same thing that we just saw in the previous example. We could select on miter, but before we do that, we'll notice that there's an option here called Next. If we click on Next, we'll notice that the lines are changing inside of here. That's because when you have two numbers which are exactly the same, such as two number threes or two number twos, you can tell which one of these materials needs to go past the other material. You can set that priority. So by clicking on Next, you can get all the different variations of number threes and number twos, or whatever the same number, and then tell them to cross each other so that you have the right material going past the correct material. Now, if we wanted to miter these two together, we could. If we selected the miter button, notice how it's now created a miter joint between these two different walls. Now, I realize this is kind of a strange wall condition, and if you look at this inside of the 3D view, you'd really notice it because we have the exact same type of wall in both locations, just one's flipped from the other. So one of the things that we could do is we just hit escape a couple times on the keyboard. I can select on this wall, and then I can click on the double arrows here in order to flip that wall to the other side. You'll notice that we still have that miter condition in place, but now all the different materials are now cleaning up with one another. Now let's zoom out and look at the third option, where we have this odd angle. This will be the option that will give us the most options as far as cleanup. Select on the wall, come up here to the wall joins, click at the intersection of those two walls. You'll notice that we have the option to butt these walls together. We could miter the walls. If you select on miter, you can see we now get that miter. Or we can square off the walls, which will actually square it off at the end. So if we would select on next, you can go through our different options as far as how to square off this wall at the end. Whenever that's all said and done and you have the walls the way you like it, you can just hit escape a couple times on the keyboard to get out of that command. Just know that you can control the way that your materials come together by one, going into the properties of the wall and adjusting those numbers 1 through 5. And second, by using your wall joints tool to control the way that the materials join together. Revit has two ways to add sweeps and reveals to walls. And if we zoom into this wall, what we can see is that we have some sweeps, such as this brick, and a reveal, like this removed brick, inside of these walls. Now, these are sweeps and reveals that are actually part of the wall type. And we can find those by selecting on the wall, going to Edit Type, because it's part of the wall type. If you don't see the picture of the wall over here, make sure to select on the Preview button so you can see the picture of the wall. Make sure that you're also on a section view by clicking where we have View and then clicking on Section. Then next to Structure, select on the Edit button. And now if we zoom in, we can see this is the sweep. The parapet cap is a sweep. And these are the reveals that are taking the material out of the wall. And those can also be found where we have the Modify Vertical Structure option, which includes our sweeps, which are at specified heights and specified shapes, as well as our reveals, which have the same properties. But these are just the kinds that are added into the wall by default. We also have options as far as adding them after the fact, so not actually part of the wall, but as a separate entity. Those are also sweeps and reveals, and they can be found underneath the Architecture tab by selecting where the word wall is located. And you have a wall sweep and a wall reveal. If you select on wall sweep, you can then pick what shape would you like to use. In this case, we only have this cornice option. But I will point out that if we select on Edit Type, we can then come in here to where we have our profile. Click, and then choose one of our loaded in profile shapes off of the list. And this could be any profile shape that we've created. It could be a custom profile shape, or it could be one from Revit's library. Now I'll just go with the default profile shape, because that's okay with me. If we want to assign a material to it at this point, we could. That's the reason why the brick looked like it was vertical as opposed to horizontal in the walls originally. But in this case, we'll just leave it as by category. I'll click on OK. And now if I wanted to add that wall sweep to the wall, I could do that. Move to the location where I'd like it on the wall. And this works in elevation view as well. In fact, it's a little bit more accurate than elevation view. I could click in order to place that along my wall. If I did the same thing over here on the other side, you kind of notice how it's already trying to just line up with the other wall sweep. And if I click in order to try to place it, it'll then place it in the location that I'd like it to be located at. But they also have the option for reveals, and the reveals work the same way. If I hit escape a couple times on the keyboard, my next option is to come over here to wall, select on wall reveal, and then if I would move either up or down on this wall, I could add a reveal wherever I'd like it to be. And once again, this could just be a profile shape that I could control, which would allow me to control how this works with the wall. One other thing that I do want to mention is right now I'm just taking these from left to right. We do have an option to go vertically as well with our sweeps and our reveals. If we came back over here to the wall, I can either select on wall sweep or wall reveal. For this example, I'll just choose the wall reveal. And we notice that we have an option for either horizontal or vertical. And this is an option you have with the sweeps as well. If you select on vertical, and then you go across either from the bottom or the top, they'll have the option to make this reveal go either horizontal or vertical. In this case, I'll just place it right here. I'll zoom out. I'll either hit the escape key in order to actually finalize the placement. And when I do, we can now see that I have this reveal going through the wall. But this is actually a great example, by the way. Whenever you have a condition like this, where it's trying to bust through an already placed either sweep or reveal, oftentimes we'll have a hard time actually cleaning that area up. So you always need to be a little bit careful whenever you're placing these sweeps and reveals, because you may need to place multiple sweeps and reveals in order to get these to clean up appropriately with one another. Now, one last thing I want to mention is that, as said, you may need to place multiple ones in order to get them to clean up appropriately. What that indicates is if I would select where this sweep that I placed in earlier was at, I could click on the little dot and I could pull this across. So maybe I can move it so it's right even with where the reveal is at. Then my next option is to place another sweep just for this portion of the wall. I can come up here to the wall, select on wall sweep. Then I can make sure that I have horizontal selected. Come over here, get it all lined up. Or get it close to lined up. I can always move it after the fact. In fact, in this case, it may actually be easier. Then I can select where I've got that sweep I placed. In this case, I'm going to select the right side of the view cube so I can see it straight on. Then I'm going to click on the little dot, pull it across. Remember, I can always move it later, so I'm just going to use the move command, move it down, and then move so that they're now lined up with one another. Click on the corner of this view cube, we can now see that I have that in the correct spot. This also works not just for the ones that you've placed, it also works for the ones built into the wall. So if I would zoom in here and I wanted to take this brick back to this point, I could do that. Click here, select on the dot, pull it back to the location I'd like the brick to be, and then click in order to just move that brick all the way back to the location of that reveal. A wall return is where the wall, or actually the materials that make up the wall, return back in toward the building. For this example, if we zoom into the left-hand side, we can see that right now we have our sweeps and reveals and they stop right at the end of the wall. For that matter, our materials on the outsides of the walls just stop right at the end of the wall. What I'd like to do is adjust the materials so that they return back around the edge of the wall, and then do the same thing with some of our sweeps and reveals. Let's start with the materials that make up the wall. If we select on the wall, the next thing we can do is go to Edit Type. Click on Edit Next to Structure. Then we'll notice that we have some options here for wraps. What this indicates is that this is the material that would wrap if it would wrap around the end of the wall. For this example, I'm going to clear the check mark next to air infiltration, and the plywood sheeting, so that the only material that will wrap here will just be this one course of brick and CMU units. For the default wrapping, you'll notice that there's two different options. One's at inserts and the other's at ends. If we use at inserts, it indicates if we place a window or a door inside of the wall, do we want to have the brick or whatever material wrap where that door or window inserts in to the wall. Right now, we'll just leave that at do not wrap. I would like to adjust it at ends because that's where we're really returning the materials at the ends of our walls. And now we have the option to either return the material on the interior side of the wall or on the exterior side of the wall. And since I want to wrap the CMU in the brick, that's on the exterior side, so that'll be what we select. Click on OK twice. And when we do that, we can now click off of the wall and we can see that the material is in fact wrapped around the outside edge of our walls. Even if we look at it in a plan view, we'll see that those materials are wrapped. So if we double click on the level 1 underneath floor plans and then zoom in, we can see that just those materials that we put a check mark next to have now wrapped around the outside edge of the walls. To make that a little bit easier to see, I'm going to add a little bit of color. So I'll come down to the visual styles and turn that to shaded. And now we can see, here's the red, now it's wrapping around the outside edge of the walls. Now the next thing I'd like to do is get out of this view and go back to our 3D view, because I want to now return our sweeps and reveals around the edge. In order to accomplish that, I'm just going to zoom in here toward the bottom of the wall. I'm going to return one of the reveals and one of the sweeps. To accomplish that, we'll just select on the wall, and then we have the option to modify returns. If you select on modify return, you'll notice this blue shape, and that's the shape of the profile shape that makes up the sweep and the reveal. If we click where that shape is located at, it will return it around the wall. We can do that with each one of these reveals as well. After accomplishing that, we'll notice that it didn't take it all the way to the back side of the wall, so that's still a manual process. So what I usually like to do is select on the wall, come here to the front of the view cube, spin it around, zoom in, find the dot there at the front, and then pull it to there. And do that for each one of these conditions. In this case, we're pulling that reveal over to remove brick material away from the wall. Now I'm going to pull this over, stretch it back. And now let's take a look at it at an angle. We zoom in here. We can now see that we've removed material around the corner. And we've added material here at the transition between the brick and the CMU block. Sometimes with conditions such as siding and brick ledges, you'll want to have your outside materials stretch down a little bit below the bottom part of the wall. And I'll get asked, is that possible to do? And the answer is yes, you can do it. All you need to do is select on the wall, find your base extension distance associated with that wall, then give it a negative number. Negative because negative means go lower in Revit. In this case, I'm going to call it -8 inches for the base extension. And by doing that, and if we zoom out, we can see it a bit better. We now have an 8-inch brick extension, or in this case, a CMU extension, at the bottom of the wall. Now Revit walls work with this condition. In order to make your Revit wall work, these are the steps that you need to do in order to create a wall that can stretch down like this. Start by selecting on your wall, go to Edit Type, then select on the Edit button next to Structure. Make sure that your view is currently a section view, and then zoom in toward the bottom of your wall. Now where you have your Modify Vertical Structure options, select on Modify, and click on the material that you'd like to have the functionality to stretch down, or actually just be affected by this base extension distance. Make sure that that material is unlocked. If you want multiple layers of material to be unlocked, click and then unlock that layer of material that you want to extend down. When you finish that, you can come over here to OK, then on OK. What will happen is then that layer of material will stretch down as well. In fact, I'll zoom in here and then I'll undo, and we'll see if we can see a slight difference in the overall thickness of the material that just got stretched down. So I'll come up here, I'll hit undo. Notice how this material is now thinner than what it was before. It was almost to the outside edge of this block before, and now it's only going to about the middle of it. And that's because by undoing what we just did, that other layer of material then became blocked, which forced it to come right back up here again to the base of the wall. So by selecting on the wall and adjusting the base extension distance, you can have that brick ledge or that general drop of material on the outsides of your walls. Just remember that you do need to unlock that material by going into the type properties of the wall, selecting on Modify, then unlocking the padlock to allow this flexibility. As you're modeling inside of Revit, sometimes you'll have conditions that you need to clean up, such as the joining locations of your wall with either your roof or your flooring conditions. And you can join these together by using the Join Geometry tool. Start by selecting on the wall, then coming up to Join, which is actually Join Geometry. Select on the wall, then select on your roof, and it will automatically clean up the materials between that roof and the wall. Now let's do the same thing between the floor and the wall. Select the wall, then select the floor, and notice how those materials automatically clean up with each other. Now, the reason why the materials clean up is very much the same as how when you have two walls touching each other, why those materials clean up. There's an internal hierarchy ranging from the number 1, which is the highest in importance, to the number 5, which is the lowest in importance as far as the cleanup is concerned. If we take a look at our walls, we can select on the wall, click on Edit Type, then select on Edit next to Structure. We'll find the numbers ranging from number 1 all the way down to number 5. Number 1 is the most important object in that hierarchy. Number 5 is the least important object in that hierarchy. Number 1s are always solid. Nothing goes through a number 1. Everything goes through a number 5. Number 5s always stop whenever they hit a number which is above them, because a number 4 is higher in the hierarchy than the number 5. But a number 1 is the highest in that layer priority hierarchy. So that nothing goes through a number 1 because nothing is of a higher importance than that function, that layer number 1. And these same 1 through 5 are built into our floors as well as our roofs. And let's take a look at that by clicking on the OK button and OK, selecting on the roof, clicking on Edit Type, clicking on Edit Structure. And here we can see the 1, 2, 4s, and it will go up to the number 5. You can click on OK and OK, and then select on the floor, go to Edit Type, select on Edit Structure, and here we have that same 1s and 4s, each one of them having their own priority. And that's the reason why when we told these items to join together, the materials automatically knew how to clean up because all the 1s, 2s, 3s, 4s, and 5s cleaned up appropriately based off that number sequence which was assigned.